Okay, everybody, welcome to, this is the third lesson of the marking period. This is called KEQ and ICE. Now, last time we created things called equilibrium expressions. And remember we said that's the ratio of products to reactants. Well, the limitation here is in order to plug stuff into this, I have to have equilibrium concentrations. Now, if I don't have equilibrium concentrations, well, I can't plug concentrations in there. Now, the problem that we have today is, notice, I'm giving you what you initially have. Not finally, not equilibrium, but your initial moles, initial overall concentrations. Recall that when we talk initially, we have initial stuff in our what we would call our reaction chamber. It's saying initially we have I2, was a student once.
Aha, good one.
And H2. Oh, good one. Then, but notice they didn't say that we had any HI. So that means we'd start off with no HI. But my friends, things change. Oh, yes, they do. And we get an equilibrium established. So we probably really should add this in eventually. At a certain point, you're going to have equilibrium concentrations of I2, H2, and the new HI that's here. All right. So we're going to have to figure out what these equilibrium concentrations are, and then we can simply plug that into our beautiful equilibrium expression. Now, of course, we make you work a little bit here. Notice I didn't come out and tell you what the initial concentrations were. I told you how many initial moles and how many initial moles and the volume of the reaction chamber. So we have to use that. Now let me clean up a little bit. Let me hit pause. So we want to calculate the initial concentrations of H2, I2, and HI. Notice that these have been written here. When we do that, of course, that's moles divided by the volume. So we have, you have to read carefully, I almost miswrote right there, 0.180 moles of I2, and we have 1.00 moles of H2, and we have, remember we said initially, we don't have any HI at all. And you have to make certain to divide these by the volume, by the volume, by the volume. Well, 1 divided by 0.5 is 2, so that's originally a 2 molar concentration. The second one originally is a 0.360 molar concentration. And that one down here is still 0. Now, notice there's a key to this. We just found out what the equilibrium concentrations of the initial concentrations were. We need to find out what the equilibrium concentration of I2 is. Notice it says here on reaching equilibrium, we have 0.020 moles of I2. So if you notice up here, I said how much I2 I had initially. Oh, could someone remind me what was that initially? Yes?
It was 0.360 molar.
Great, 0.360 molar. That's initially. But once we get to equilibrium, I'm sorry, let me do that again. That is I2, at equilibrium, that's going to be equal to the number of moles I have at equilibrium divided by the volume of the container. So that's a 0.040 molar solution. So initially we had I2, but by the time I reach equilibrium, I have 0.040 moles per liter. So up top, we found out what the initial concentrations of H2, I2, and HI were. And we also found out here what the equilibrium concentration of this was. Now, could someone remind me, what is the initial concentration of H2? Was that 0.36?
No. It's 2.
It's 2, thank you. This was 0.36?
Yeah.
Okay. 0.0 or just
Point
0.36, thank
0.
you. And we had none of that. Now, guys, at equilibrium, we had 0.040, is that right? So that means there must have been a change. We started off with that concentration right here, and we wound up with this concentration. So did this increase or decrease? It went down. So what that means, guys, everything on the same side, everything on this side, had to decrease in concentration. And what that means, everything on that side had to increase in concentration. Stands to reason, right? If I'm decreasing this side, I have to be making more of that side. All right. So then what's the difference? 0.360 minus what is 0.040? Yes? 0.22, no. I think it's, no one can do math here? So what that meant is the change was so, you decrease the amount of I2 by this amount. Now we have to therefore figure out how much of that, how big the change was here, and how big the change was here. Well, notice here, guys, I have a 1-to-1 ratio. So what that means, for this change, I'm going to change by the same amount here. It's 1-to-1. So I'm going to decrease this side by 0.320. And when I do that, 1.68 is the concentration at equilibrium. Now be careful. How about on this side? I know it's going up by a certain amount, but it's a 2-to-1 ratio. So what is double 0.320? Yes?
0.64.
That's right, thank you. 0.640. So that's mental math even Mr. Sigelki can do. 0.640. My friends, we have found out all of the equilibrium concentrations. So now we just go back to the skill we practiced last week, and we plug those in to an equilibrium expression. Why don't we take a moment and try to write the equilibrium expression for that system? So viewing audience, while you were waiting for us, we came up with, thanks to Lydia, shout out to Lydia, this is our equilibrium expression. Products are on top, reactants are on the bottom. Now we have to plug values in, don't we, class?
Yeah, we do.
Bang! Take a look at that, guys. Notice I put the equilibrium expressions in. Now it's just time to solve. My class is going to solve it for me, and then I'm going to come back. Well, thanks to Lileva, shout out to Lileva, KEQ is 6.1. Remember, it's unitless, which, I mean, so there, you would be totally incorrect to write a unit here. Remember, normally we say write a unit, but this actually is something that's unitless. Okay? So that's how we do it.
That's it for that outfit.
This is, shout out for Aaron T. And,
I think
oh,
we've been tested.
no, Aaron, I was going to say Maggie. Aaron and Lil Calais, that's right, and McGrath and Ladaya and Berto and Eli P and Maggie Z,
And Michael
Maggie Zellis. What? Do we have any time left? Oh, I have 6 more minutes of shout out I can do.
Wait, we should wrap
24 Jared Gold and Grella Verga. I mean, Bella Verga's there.
Wait, I know how to make that.
And Luis.
As your favorite.
Okay, we have to say goodbye
It's
now.
not
Izzy, it's a bow. It's a bow and arrow.
Leo says
With the snacks?
Oh,
Guys, I have to say goodbye.
no.
I'm
Leo
sorry.
says Gert quickly.
Leo, grr. Leo says grr. There you go. Bye bye.